Welcome back, grade 7s. We have one more thing we need to learn this week, and that is how to model expressions. Now, I know some of you have been a little bit confused about the word model in the past. Remember, a model is just a drawing. It's a way of picturing what's happening in your head, okay? So we have a number of different ways of modeling or picturing expressions visually, okay? And so I actually have a model of an expression on the counter here in front of you, and it is a very, very simple expression. Each cube is 1. So we have 1, 2, 3. This is about as simple as an expression can possibly get. This expression is, you guessed it, 3. Okay? And yeah, I know that's just a single number up there on the board, but this is still an expression. Okay, 3 is still, it's the expression for how many cubes are currently sitting on the table. All right, now obviously we don't usually bother to model 3, right? This is a little bit too basic. We're going to have some more complex modeling as well. So one of the things we do, of course, in expressions is we have variables. We have stuff that we don't know exactly what the number is. In this case, the most common thing we use to model a variable is a cup. Okay, so in this case, imagine that there are a certain number of cubes. I'm not going to tell you how many cubes inside this cup. I don't even know how many. I haven't looked. Okay, so there's a certain number of cubes inside this cup. Bam. Okay, and then we have 3 more cubes sitting on the countertop. Well, how would we write an expression for how many cubes we're dealing with in total? Well, we're going to assign a variable for the number of cubes inside the cup because we don't know how many there are. So there's a lot of different choices. You could use X. X is pretty standard. Some people like to use C for cup. Try to avoid that because the C doesn't actually stand for the cup itself. It stands for the number of things inside the container, okay? So bear that in mind. It's not how many cups there are, it's how many things are inside that container. So in this particular case, I'm going to use X. And my expression would be X plus 1, 2, 3. There's still 3 cubes on the countertop. So my expression ends up being X plus 3. Now, of course, you're going to be asked to model these too, and unfortunately, you don't have any cups and stuff to work with here. You don't necessarily have manipulatives because I can't send those home with you. So what you're going to do is you're going to draw this out. Basic drawing of a cup looks like that. You don't have to be real fancy, okay, guys? If you draw this little U-shaped thing that's really square, I will understand that what you mean is that that's a cup and it has some counters in it, okay? I have some students try to get all fancy. You can, but sometimes cups are awkward to draw. So we have this plus 3 more counters. We tend to draw these as circles because they're faster to draw, okay? This is not the only way that you can model an expression, of course. You'll see all kinds of things. Sometimes you'll see people taking the time to label the cup with an X. That's okay. You can do that. It's X number of counters inside the cup. Sometimes you'll see someone drawing a slightly different diagram. They'll draw what we call an algebra tile, and they'll fill it in, and they'll say, this here, oops, this here is X. I don't know how much it weighs if we're talking about a balance scale. And then they'll say that we also have 4 of these little things that weigh 1 gram each, and that can be an expression as well. All right. So this is one expression. They can get more complicated than this, all right? Incidentally, some of you are wondering how many things are in the cup. I will tell you, okay? In this case, there are 1, 2, 3, 4, 5 things in the cup. And this is kind of nice. You can use your expression to figure out how many there are. If X is 5, 5 plus 3 is 8. Okay, notice how I'm writing my work down. I write a new thing on each line, and I work my way downwards. This is how we're trying to show our math work now. We don't put everything all out on one line anymore, okay? And of course, the other option is you just put these in your hand, and you count them up. And what do you know? We got 1, 2, 3, 4, 5, 6, 7, 8. Looks like my expression was, in fact, correct, all right? So that's the other option for doing this. We're going to do another expression. Okay, this time I have 2 cups, and I'm actually going to take the time to label both of these cups. Let's not do X. X is feeling. We'll go a little alphabet soup here. We'll go with A. Okay, so we got 2 cups labeled A. And the reason I'm specifically labeling these cups A is because they have the same number of counters in each one. And this time I did actually have to look because I'm counting out the same number of counters, but I'm still not telling you. So A is still an unknown variable in this case. Now there's nothing loose on the countertop here, right? There are no loose counters on the countertop. There's just 2 of these variables, okay? Well, if you stop and you think through the math for this, whatever is in this, there's 2 of them. If we multiply the number of counters in that cup by 2, we will get the total, okay? So our expression for how many counters there are in total is going to be 2 times A, but we don't write 2xa anymore, right? We write 2A. So this is going to be 2 times the number of counters in the cup, which I'm going to represent by A because I labeled my cups A, all right? Now, one of the cool things about this, and you're going to learn this later, this is literally 2 cups, and so it's 2A, and that's kind of a convenient way of remembering it. If I were to then add 3 more cups with the same number of counters in it, you could go, okay, that's 2A plus another 3A, and they add up to 5A. So that's kind of cool. You're not going to be doing any adding of this kind of thing yet. That's for later, but it's kind of cool to know that that is how it works out. And of course, that's how it works out always, right? That's how multiplication works. The first time you learned multiplication, you learned it as repeated addition, right? You did skip counting. And so this is basically the same thing. It's skip counting, but with variables. All right, so you probably want to know the solution to this. Are we ready? There are 3, count them, 1, 2, 3 cubes in each cup. So if you do the math, you should be able to figure out how many cubes there are supposed to be in total without having to count them. This is 2 times the variable, so that's 2 times 3, which means we have 6 counters here. Let's check them out. Tip them into my hand, see if our math was correct. Here we go. So we have 1, 2, 3, 4, 5, 6 cubes. Looks like we were in fact correct. We did the math properly. Okay, so that's how this works. We have 1 more to go, a little bit more complicated. Okay, so this time, not only do we have some loose cubes on the counter, okay, and I'll line those up so you can see them a little better. 1, 2, 3, 4 loose cubes on the counter. We also have, oh, let's make it complicated. Why not? We have 3 cups. Three cups with an A on the side. And they all have the same number of counters in them. I'm having trouble. Move these over. Okay, and so we need to write an expression for how many counters there could be in total sitting on our tabletop. Okay, so, well, we know that there's 4, so let's start with that. Okay, and we call this the constant because we know that whatever else happens here on this countertop, at least there's 4. We can count on that. That's constant, okay? But we don't know what's in these cups. We don't know what variable it is, right? It could be anything. What we do know, though, is that the same number is in each cup, and there are 3 cups, okay? So if we take however much is in one of these cups and we multiply that by 3, that's how many we're going to get here. So our expression for this part is going to be 3 times A, which we write as 3A, okay? So our expression is 3A plus 4. Now, you guys want to know, right, how many there are? Let's stop and think about the math. If there are 2 counters in each cup, that means 3 times 2 is 6 plus 4 is 10. If there's 1 counter in each cup, that means 3 times 1 plus 4 is 7. Let's find out how many counters are in each cup. Nothing at all. It's a 0. Okay, there's nothing in any of these cups. They're completely empty. So our variable here ends up being 0. So this is 3 times 0 plus 4. Well, we always do multiplication first. So 3 times 0 is 0. And then we add the 4, and our final number here is 4. This is all the counters there ever were on the table. Who knew? Okay. So that is how you model expressions with cups and counters. You'll see other possibilities. Sometimes we talk about packages of, I'm in the middle of filming a lesson. Sometimes we talk about packages of candy and how many Skittles are inside the package of candy. We might talk about, there's a can and the can has this number of beans in it, that kind of thing. Okay. So whatever it is, it doesn't matter what the package is. What matters is you're going to use a letter to stand for it because it's something that you don't know what it represents. Okay. So go ahead, finish that assignment, and I will see you next week.